There's a lot of operating systems nowadays, such as Windows, Linux, and macOS. Today, we're going to start off by the definition of Windows. Who created Windows? When is it created? And what is Windows? Windows was created by Microsoft Corporation since 1985. It provides a user-friendly interface for personal and business use. It was gaining more and more popularity due to the versatility in range of software and hardware. Windows have a lot of unique features too. The first thing first is the Cortana. What is Cortana? Cortana is a voice-activated digital assistant similar to Siri or Alexa. It was powered by AI. The second one is the control panel. Control panel allows users to configure and manage their computer resources. Last but not least, the internet browser. The internet browser is one of the reasons why people is using their computers nowadays. Initially, the Internet Explorer is now the Microsoft Edge for the browsing website. Okay, this is a overview of our I/O system. As you can see, the definition of this I/O system is it allows computer to communicate with the external devices like printers and mice. And why is it so important? There's an I/O subsystem standardize the interface for devices and enhance system performance by managing resources like CPU and RAM. There are many types of I/O devices nowadays. First one is the storage device. The example for storage device is the hard disk drive, known as HDD. It is a magnetic storage of large capacity. The second one is a solid state drive, SSD. It is a flash memory and it is faster and more durable. The third one is the USB flash drive. It helps to transfer files between the computers. Okay, the second devices is the communication device. For example, modem. It helps to convert data from telephone lines. Second, the router. It directs data between network. The third devices is the user interface device, such as keyboard. It helps to input text and commands. Mouse. It helps to navigate the screen, and monitor. It displays the visual output.
Moving on to I/O hardware. What are the components of I/O hardware? I/O hardware is a number of specific units of computing hardware that is used to assist the operating system to gain access to a device like a disk drive, a printer, and others. These devices are installed within the motherboards. These usually incorporated their own controllers that enable them to easily respond to queries from software that run on them or even whose operations they command directly from an application program. This part will have some discussion on the parts of I/O hardwares. Moving on to the example of I/O hardware. What are the examples of I/O hardwares? Buses. A bus is a means of transporting data between parts of a computer such as CPU, the memory and other equipment known as I/O devices. This can also serve as a medium of data transmission and also plays an important part in internal communication within the computer system. There are different types of buses. One of them are data buses or address buses. Moving on are controllers. Controller is a hardware device that controls the transferring of data between the computer terminal and peripheral equipments. It works at the same level, helping to derive the information from the format of peripheral devices in a format understandable by the CPU. Lastly are ports. Ports is a physical interface on the computer to which an I/O device can be connected. It also serves as the connection point for external devices such as keyboards, mouse, printers, and storage devices. The type of ports are serial ports and USB ports, which is versatile port that is widely used by different devices. Finally, there is device drivers. Device drivers are software components that enable the operating system to communicate with the hardware devices.
Now, I would like to explain about the part of I/O software, which is the role of the subsystem in an operating system. The I/O subsystem can be fit for providing a facility of interfacing all the I/O device. At the end of this section, we are able to see how the I/O subsystem is able to post the information to the device driver and input-output units such as the printers, keyboards, and the mouse. This means that a device driver is categorized as one of the software type because it controls a certain type of the hardware device that would be regarded as being an intermediary between the device and the operating system that uses it. It controls the device and it knows the language of the device more than any other entity because it is a device driver program. The following is the key functions for the I/O subsystem in an operating system, which are monitor situation of operations, manage buffer and caches, and also provide ways to solve error. So, how about the operating system manage I/O request? And what is the difference between buffering, caching, and spooling? Buffering is a common method used to smooth the transmissions process when transferring some information between two devices at different speeds. It can preload data into a reserved area of memory. The main use of buffering is input and output. Moreover, it also can be used to modify temporary storage of data. And the purpose of the caching is reducing the accesses to the underlying server storage. It stores the accesses data in a faster storage in order to reduce the access time. When we need to access the cache file, it will directly find the file from the cache's instance. This will improve the performance of the device because it no need to find the file from the slower I/O device. And the last is spooling. It's a process to place data in temporary working area for another program to process. It is suitable for a device which cannot handle multiple requests at once, such as printer. For example, with printer, there is a resource to be accessed to by many processors. The spooling can help to manage the tasks that need to be done. The data will be processed by using first-in, first-out manner. This main use is when processors share some resource and needed to have synchronizations. The last present of my part is challenges in I/O system. There are storage performance, speed mismatch, network delay, risk of security, and also virtualizations overheads. The first is storage performance. The rapid growth of data generation demands not only need bigger and faster storage, but they also need efficient access machines. The secondly, I/O devices are slower than processor and it causes delay in data transfer in order to cause slowing down the system. The third is network delay. In systems spread over different locations, like cloud service, sending data between devices can cause delays, especially over the internet. The fourth of the challenge in I/O system is risk of security. I/O system handle sensitive data such as private information in order to make them target for hackers. Protecting this system from attacks is a big concern. The last challenge is virtualization overhead. In virtual machines, managing I/O can slow down the things because of the extra layers of software between the hardware and virtual systems.
With technology getting better and better, what are the future trends in I/O system? Firstly, there is increased uses of AI and machine learning in I/O system. Artificial intelligence or machine learning is likely to play a significant role in optimizing the process in the future. These technologies are able to predict I/O workloads, automate the entire system, making it streamlined and efficient. Second, there is development of faster and more efficient interfaces. Newer and faster data transfer standards such as USB 4 are becoming more widespread. They offer higher data transfer rate and lower latency, leading to improved performance in applications, replacing traditional electrical connection to increase data transfer speeds and reduce signal losses. Finally, there are integration with cloud and edge computing. The rise of cloud and edge computing is driving the need for I/O systems that can seamlessly handle distributed data processing efficiently. The future I/O system will likely be optimized for high-speed connectivity to the cloud with lower latency and higher throughput to support faster real-time data analysis.
So for the conclusion, Windows OS plays key roles in personal and business computing because it's flexible, user-friendly, and works well with both hardware and software. A crucial part of any OS is I/O management, which allow the computer to communicate with devices like printers or keyboards. Windows improve performance using three techniques: buffering, caching, and spooling. Device driver act as the link between the OS and the hardware. However, challenges like speed difference, network delays, and security risks still exist in I/O management. Looking ahead, advances in AI, faster data transmission, and cloud edge computing offering promising solution to this problem. I/O system will remain essential for fast and efficient computing. So that's all for our presentation. Thank you so much.